Okay, hopefully this time I actually start the video, because I did about this problem before, but halfway through it before I realized that I was not filming. Okay, the problem is you're hanging a sign, and the sign is apparently made out of lead, and it weighs 500 kilograms. Just humor me. You have 3 ropes, one connecting right to it, and 2 other ones connecting to a concrete support beam that can hold an unlimited amount of weight, we'll say. These ropes are rated to hold 5,000 newtons. The question is, what are each one of, well, the question is, can these ropes hold this? And to find that, we're going to have to find out each one of these tensions. First thing we're going to need to do is let's find out T3. Let's see if this one can hold all the weight, since it's just holding all the weight. And to find out we have force equals mass times acceleration. In this case, mass is 500, and our acceleration is 9.8 due to gravity. And we get 4,900 newtons. Okay, that's a lot, but it's under our rated tension strength, so we're okay. Now, right after that, you can see that these two will be able to hold it because it'll be less than 5,000. You have to realize that because these two are sharing the weight, whereas this one had it all and it still held it. So the next thing we need to do is make some imaginary components to this. So first thing we're going to do is draw in TX1. We'll call this TX1 because it's the x-axis, and we'll call this TX2. Now if you notice, this one is slightly longer, and it would be in real life since this angle is higher. But TX1 and TX2 have a net force of 0. You know that because the point at which they intersect, it's not moving. Okay? It's there's no net force, there's no moving. Because if you pull on them, nothing is happening. So you know those two are the same, and that's going to come in handy later. TX1 equals TX2. And from now on, we can basically just use TX1 in place of TX2 since we know they're the same. Next component we need to do is TY1 and TY2. Now, this is important. Just like this one, those had to equal out this, and then these two have to equal out. So TY2 plus TY1 plus TY1 has to equal T3, which we already figured out to be 4,900. But doesn't matter quite yet. So the next step that we need to do is we need to figure out TY1, and just let me change these around for close TY1. Call these both 2 just for sake of what I've done so far. So let's find TY1. Well, TY1, actually no, first one. This angle equals 70. We know that because these are 2 parallel lines, and I can't think of the proof right now, but there's a geometry proof that says that those two are the same, and you can see. So that makes this one 50 as well. So we're trying to find TY1. Okay, well, what's TY1? Well, it's opposite and adjacent. Okay, so TY1, actually say that, let's do that one more time. Tangent of 70, since it's tangent because it's opposite, it's opposite over adjacent, and our opposite, opposite is TY1 over adjacent is TX1. To get TY1 by itself, you need to multiply, and you should know that from algebra. If you don't, you should probably not be watching this video. So TX1 times tangent 70 equals ty1. Okay, we've got that. Now let's go find ty2. We're going to find it the same way. Tangent of 50 equals opposite ty2 over adjacent tx2. Multiply to undo, ty2 equals tx2 times tangent 50. Okay, now what did I say earlier about tx1 and tx2? They can be basically the same since they are the same number. So let's call this tx1, and actually that's going to be crucial to figuring out this problem. Now we know ty1 and ty2 in terms of tx1. So let's go back up here. Actually, did I not write that down? Oh yeah, no I didn't. So we know that t3 equals ty2 plus ty1, right? Those two. Well, now we know ty2 and ty1. So let's substitute those in there. tx1 tangent, I'm just going to use brackets, tangent of 70 plus, remember plus, we're going to say tx1 again because they're the same, they're one and the same. Tx1 and tx2 are the same thing. tx1, let me go over here, actually down here, tx1 tangent 50. Okay, now this is pretty crucial part. If you notice, you have two tx1s here. So you can kind of combine and kind of factor these together. T3 equals tx1, because tx1 times tangent 70 plus tx1 times tangent 50 is the same as saying tx1 tangent 70 plus tangent 50. Because, and you'll notice that, and if you don't understand this from algebra, let me explain it here a second. If you multiply distributive properties, multiply those out, you're going to get exactly that. Okay, well, we can't solve that right now because we don't know T3, but we do actually. T3 is up here, it's 4900.